In this lesson, we're going to be looking at finding the derivative of a function at a specific point A and doing this algebraically. First, we're going to review our prior knowledge. So you'll recall in previous lessons we've drawn some function. That function can look any way we want, and we've placed a point at x-coordinate A, which has a y-coordinate of f of A. Then we've wanted another point that's distance isn't too far away, and that distance we called h. And so this next x-coordinate was a plus h, and we brought this up to a point which came over to a y value of f of a plus h. And then initially we found the slope of the secant line. So here's our secant line. But if we wanted the actual slope right at f of a, we would bring that h value as close to 0 as we could. And when we were done, we came up with this formula where the top, remember, is the difference of our y values, f of a plus h minus f of a. The bottom is our difference of our x values, which is h, because that's the distance between my two x values. And I'm taking the limit as that distance goes to 0, and that gives me my derivative at a, which is the slope of this red line. All right, so let's jump into a problem here. And in this problem, we have a function, and our function is going to be 1 plus x squared, and we are finding f prime at 1. That means that's going to be our a value. 1 is our a value, so let's just mark that here. So in our formula, that number a is 1 all the way across here. So when we rewrite our formula for the derivative at 1, it's going to be the limit as h approaches 0 of f of 1 plus h minus f of 1 all over h. All right, so now what we need to do is substitute f of 1 plus h. So we go up to our f function here and we say, okay, I'm going to plug in 1 plus h into my function, which means I'm going to replace x, which is down here, 1 over x squared, with 1 plus h. So I get 1 over 1 plus h squared. So I go into my formula. I've got the limit as h approaches 0 of 1 over 1 plus h squared. The next thing I'm going to plug in is just 1. So I'm like, oh, okay, f of 1 equals 1 over 1 squared, because my function again is 1 over x squared, and that is simply 1. So I plug in 1 here, and the whole thing is over h. Now you'll recall from last unit, when we had a fraction and a fraction, we would multiply top and bottom by the denominator of the fractions and the fractions. So we're going to multiply top and bottom by 1 plus h squared. And when we do so, we want to make sure when we multiply that we multiply each term by this. So let's just scroll down a bit so we've got some space to work. There we go. And we've got our limit as h approaches 0. And by the way, if you feel confident in this, I would encourage you to pause and try and finish this whole thing out and then come back and look. So we take 1 plus h squared times this fraction. We just get 1 because the denominator cancels. And in the second case, we get 1 plus h squared. And that whole thing is over multiplying out the denominators, h times 1 plus h squared. All right, so let's just give ourselves a little more space here. All right, and we now have the limit as h approaches 0, 1 minus. Now I need these parentheses so that when I distribute, I multiply everything by the negative. So right now I'm just going to square my binomial. So I've squared my binomial. And I want you to notice I keep writing the limit as h approaches 0 because I have not taken the limit yet. So now this equals the limit as h approaches 0. Now I'm going to distribute that negative. So I get 1 minus 2h minus h squared all over h times 1 plus h squared. And now I see that the 1's are going to cancel. And I can see that I can factor out an h. So I've got, as h approaches 0, h and negative 2 minus h all over h 1 plus h squared. And now the h, which was the reason I couldn't just plug in 0 all along, cancels out. And I am now able to plug in 0 on top, which gives me -2, on bottom, which gives me 1, and I get my answer of -2. And remember, at the very beginning, I was trying to find f prime at 1. So let's just make this make sense to ourselves. All right, I've pulled up my graphing calculator, and I've put in the function 1 over x squared, and I'm going to choose my decimal window. So there's a nice window, and let's just grab that graph, oops, and pull it over here. And we see that on this graph, we were interested in our slope at 1. So here's 1, and if I go right here, there's my slope of my tangent line. So it makes sense. Our answer is -2. It's definitely steeper than a slope of -1, and it's negative, so that looks good. All right, so we're ready to go on to our next problem. And in our next problem, we have a new function, f of x equals root x, and this time we're finding the derivative at 25. So that's going to be our a value. So this time, where we have a, we're going to replace it with 25 all the way across. All right, so f prime at 25 equals the limit as h approaches 0 of f of 25 plus h. So let's put that in here, the square root of 25 plus h minus, well, what's the square root of 25? That's just 5 all over h. And before we go any farther, let's just recall what we think is going to happen. This is an easy graph because we know what it looks like. It increases at a decreasing rate. So we're going to expect a positive answer and not a very big number because this becomes less and less steep as we go along. All right. You'll recall that when we do these problems, we would always multiply by the conjugate, and I would encourage you to pause right now and try this out on your own. All right. Hopefully you're back and seeing what we're doing here. We're multiplying by the conjugate, root of 25 plus h plus 5 on top and bottom. And here we go, the limit as h approaches 0. We multiply with those square roots and we just get 25 plus h. We multiply 5 times 5, which is minus 25. And then on the bottom, we multiply our denominators. Make sure you have parentheses right here. That is important so that what we write is mathematically correct. All right, so now the 25's cancel. That's nice. Once they cancel, the h's are able to cancel, and we're left with a nice expression. We'll scroll down and give ourselves a little more room. Oops. Where we've got the limit as h approaches 0 of 1 over the square root of 25 plus h plus 5. We plug in 0 and we get 1 over square root of 25, which is 5, plus 5 gives us 1/10. And like we expected when we looked at our graph up above, for our slope at 25, our answer is positive and a fairly small number. Now, there's more than one way to find those derivatives algebraically. So up till now, we've always had h going to 0. But another way to do this is by taking a point here and saying, well, this point, which is at x, we just want it to get closer to a. All right? And so in this case, what we're working with is an a. We're plugging in a. So just like before, our y value is f of a. But we plug in x for the other one, and for that one, our y value is f of x. And what we're going to be doing here is keeping a stationary, but x can move. Now let's start with the slope of the secant line, which is this red line right here. In the slope of the secant line, I subtract my y's, which would be simply f of x minus f of a, over my x values. So we're just doing delta y over delta x, which always gives us slope. Now to find the slope of our tangent line, which I'll draw in here, so our tangent line is going to look more like this line, we need to be moving this point, which is at x, closer and closer to a. So we're going to be taking the limit as x approaches a. So now our formula looks like this. The limit as x approaches a, and then the same formula up here, our y values are still f of x and f of a. Just know that when I move this value in like this, then my f of x comes down like this, and my x comes over like this. Okay, so the f of x and the x values are moving. A stays stationary. And on the bottom, I have x minus a. So I'm still subtracting my y's on top, my x's on bottom. The difference is I'm taking the limit as x approaches a. All right, so let's use this new formula here. Let me write it here again so we can just see what it is. The limit as x approaches a of f of x minus f of a all over x minus a. Now in this problem, we're given the function a polynomial, x squared plus 8x plus 9, and we're asked to find f prime at 2. So that is our a value. So we're going to rewrite this as the limit as x approaches 2 of f of x. Remember, x is not my stationary value, so those x values keep changing, minus f of 2, which is stationary at 2, all over x minus 2. So now we just start substituting in. Limit as x approaches 2. What does f of x equal? It equals this expression up here. So we're going to put in x squared plus 8x plus 9. What does f of 2 equal? Well, let's just figure it out. F of 2 equals 2 squared plus 8 times 2 plus 9. So let's see, 4 plus 16 plus 9 looks like 29. So we're going to put in minus 29 all over x minus 2. So now we carry on. The limit as x approaches 2. We can simplify the top, combine our constant terms. We get minus 20 over x minus 2. And we're hoping that this is factorable. So limit as x approaches 2. And we need, let's see, factors of 20 that subtract to 8. It looks like 10 and 2 should do the job. Plus and minus. And now this is working out just beautifully because my x minus 2's are going to cancel. And I can simply plug in 2 and I get 12 for my limit. I've pulled out my calculator and I've gone ahead and put in that graph just so that we can see what the graph looks like and make sense of our answer. So just drag this over here and, oops, didn't mean to write on it. All right, so when we drag this over here, remember this was to find f prime at 2. So I think my window's clear enough for us to see at 2. This is just a parabola, so it's going to keep going up. And at 2, we would expect this to be rather steep. That's a pretty bad drawing, but an answer of 12 does make sense because my parabola is getting steeper and steeper. And so we can see that our slope would be positive and quite steep at 2. Which is over here. Okay, let's try another problem. Oops, well, actually not another problem. We need to carry on with this problem. We want the equation of the tangent line at 2. So let's grab all our information from the previous slide. To write the equation of a tangent line, we need two things. We need a point and we need a slope. So let's go see, where was our point and slope? Here we go. Here's our point. F of 2 equals 29. I'm going to transfer that information over here. So we knew that f of 2 equals 29 from the previous one. And the other thing we need is our slope. What was f prime of 2? Let me just look at my previous work, scroll down to the bottom, and there it is. There's my answer. It was 12. So f prime at 2 equals 12. So to write the equation of my tangent line, slope-intercept form, y minus 29 equals 12, x minus 2. And now we're done with this slide. All right, let's do one more problem where we are using this new definition to find the derivative at a certain point. In this case, we're finding g prime at negative 2. So this time we're going to do g of x, not f of x, minus g of negative 2 all over x minus negative 2. So remember the general form was f of x minus f of a, that's what we did, and x minus a. So when we have a negative, we end up with those two negatives. All right, let's carry on. So g of x is 1 over x squared, so we can just plug that in. Minus, when I plug in negative 2 squared is 4, so minus 1/4. And my bottom is going to clean up to x plus 2. And now you should all be screaming, Mrs. Young, you forgot that this is the limit as x approaches negative 2. So we better fit those in. So let's make some room. So this, we haven't taken the limit yet. So the limit as x approaches negative 2. If you're feeling good about this one, I would pause and try it on your own. All right, welcome back. Hopefully at this point you've multiplied both top and bottom by 4x squared, which is our common denominator. When we do so, we've got the limit as x approaches -2. And when we multiply the first fraction by this, we're left with 4. When we multiply the second fraction, we have x squared. And then on bottom, we've got 4x squared, don't forget your parentheses, times x plus 2. So then we're going to do some factoring. Clearly, this is going to factor into 2 plus x and 2 minus x all over 4x squared times x plus 2. Recall that it does not matter what order you're adding. 2 plus x is equal to x plus 2. So I can just cancel those with no extra work. And I am now ready to plug in -2. So we plug in -2 on the top, I get 4. And I plug in -2 on the bottom, and 4 times 4 there, right? And oh, those cancel. I don't even have to use big numbers. And I get 1/4 for my slope. All right, so that was g prime at 2. And like we've done with the other graphs, we should probably consider, does this make sense for our graph? But I think we'll do that on the next slide. So let's head over here where we're asked to write the equation of the tangent line. So let's go back and find out what was our point. So our point, we plugged in -2 and we got 1/4. I remember that now. So let's just write down our information here. So g at -2 equaled 1/4. And then g prime at -2, if I remember correctly, was also 1/4. Yep, there it is. G prime at -2 was also 1/4. So when I write my equation of my line, I'm going to have y minus 1/4 equals 1/4 x plus, oops, let's make that look prettier. All right, x plus 2. Now let's actually test this time and look at both the graph and the tangent line to see if that looks good. All right, you'll notice that I already put in the equation 1 over x squared, but then I'm also going to go down here and put in my tangent line. Now obviously I have to solve for y, so I'm going to move this -1/4 to the other side. So I've got 1 divided by 4 plus 1 divided by 4 parentheses x plus 2. So there's my tangent line. And now I'm going to hit graph. And that looks pretty good. I'm going to actually get a better window so we can see that better. I like zoom decimal for things that are close to the origin because it gives us a clear picture. And there we go. We look at our graph there and we can see, yeah, that is the tangent line at -2. So that's a really easy way to check when you're asked to find the tangent line is to graph the original function, y equals 1 over x squared, along with the tangent, and it should look good. It should only intersect at one point. All right, we've done what we need for your next homework. On your homework sheet, this is number 3, I believe, and there are some special instructions, so make sure you look at the special instructions as you go to do it. Good luck.